Hello everyone. We're going to complete chapter 1, physical measurement. Okay, I told you before that we have something called physical quantity. It's anything that we measure it in physics, okay? There are two types, fundamental physical quantities and derived physical quantities, okay? Any physical quantity, okay? Any derived physical quantity must consist of fundamental physical quantities, okay? It maybe consists of one physical quantity, one fundamental physical quantity only, just like area. It consists of length only, length power 2, of course. It maybe consists of two of three fundamentals and maybe consists of the three fundamentals, okay? We didn't get any rule or didn't get any physical relation in physics by coincidence, okay? We get it in scientific way, and to get any physical relation in the physics we must use the dimensional formula, okay? So the dimension formula is the formula that indicate any derived physical quantities in terms of fundamental physical quantities, which are mass, length and time, okay? It's just like the fingerprint. Any physical quantity is a unique physical quantity for this physical quantity, okay? So it's the fingerprint for the physical quantity. We can use the dimensional formula to get the measuring unit of this physical quantity. This is absolutely correct, okay? We can use the dimensional formula to verify the physical mathematical relation. If we have a mathematical relation and I want to know that if this relation is correct or not, we can use dimensional form, okay? If I told you an example, just like this, find the dimensions and the unit of measuring work, knowing that the work equal force times displacement, okay? Number one, if we have a relation, we must drive any fundamental physical quantity to get to get it in terms of its fundamental physical quantity, okay? Number one, we have work equal force times displacement. The force is called derived physical quantity. I must get its fundamental physical quantity. So I will say that the force equal mass times acceleration. So the work will be equal m times mass times acceleration times displacement, okay? We have here the mass is a fundamental, of course. Displacement is a fundamental, of course, but the acceleration is derived. So I can say that the acceleration will be equal velocity over time. And from this relation, I can say that velocity is a derived physical quantity. So I will say that the velocity will be equal distance over time. So I can say the work equal mass times displacement power 2 over time power 2. Okay, and I will transfer the powers here to our dimensional formula, which is called MLT. MLT, okay? The mass here, we have it having the power of 1. So I can say the work have mass power 1. We have displacement power 2. So I can say the displacement will be equal power L power 2. And the time having the power of 2, but in the denominator, okay? So I can say the time has the time of power, had the power, of negative 2. So the dimension formula of work is m power 1, L power 2, T power negative 2, okay? And the unit of measuring work or unit of measuring energy, it's the same, okay? Mass is the measuring unit, kilogram, is the measuring unit of mass. Meter is the measuring unit of length. Second is the measuring unit of time. All we have to do is transfer the powers from the dimension formula to the measuring units. So the measuring unit of work is kilogram dot meter square dot second power negative 2. Okay? I want you to concentrate with me in these notes. It's very important. Okay? We can add or subtract any two-dimensional formula in condition they are identical. If the dimension formulas we are dealing with are identical, so we can add it or subtract. If they are not identical, I cannot add it or subtract it. Okay, this is very important. If I told you this dimension formula will be added to the dimension formula. So you must know that these are two identical physical quantities or two identical dimensional form. Okay, we can multiply or divide any two-dimensional formula if they are completely different. If we multiply two-dimensional formula, all we have to do is addition of the powers of the similar terms, and if we made a division, all we have to do is subtract the powers of the similar terms. Okay, and you must know that the constant number have no dimensions. Okay, here we having an example to verify any physical relation. Okay, the movement of an object under the effect of gravity is given by the relation V final equal V initial plus gt. G here means acceleration due to gravity, so we must deal it as acceleration. All we have to do is getting the dimensional formula of left hand side and getting the dimensional formula of right hand side, and if the dimension formula of left hand side is equal to the right hand side, so this relation is correct. If the dimension of the left hand side doesn't equal the dimension of right hand side, so this relation is